Hello, we begin this video with an example. Our goal today is to find new Taylor series from some that we already know. So, for instance, we know that if we consider the function 1 divided by 1 minus x, and we consider this for values of x with absolute value of x less than 1, then this has associated Maclaurin series, the sum of x to the power of n from n equals 0 to infinity. Now, what if instead what we wish to find is what is the power series associated to the function 1 over 1 minus 7 times x? What we are doing is to multiply our variable x by 7, so we are going to do that also inside the power series. So this is going to look like, well, the sum is going to be still from 0 to infinity. And then instead of having x to the power of n, what we have to the power of n is 7n. 7x, sorry. So could write this sum from 0 to infinity, 7 to the power of n, x to the power of n. So that will be our new power series. But to make sense of this, we have to say for which values of x this is convergent. And what we know is that originally we needed our variable to be in absolute value less than 1. So now we need 7 times x to be in absolute value less than 1, which means that we need our variable x now to be in absolute value less than 1 over 7. So we know that between negative 1 over 7 and 1 over 7, for the values of x between them, our new power series is convergent. And outside that open interval, our power series is divergent. What we just did is part of a broader result. So let me write here theorem. Let's say we have two power series centered at 0 and k that is a constant. Then if we wish to find the power series associated to the function that has the variable x multiplied by k, then we can do it exactly as we did it in the previous example. If instead we want to find the power series that is associated to the function where we first find the k power of the variable and then apply the function f, then we have a similar method to do it over here. Basically what it says is that we need to substitute the value of x by x to the power of k, and then we would end up with a power series that here has the powers of x to be k times n. And if we want to take the sum, or we want to take the difference between the two power series f and g, we have to look at taking the sum or the difference between the coefficients a(n) and bn that are multiplying the variable x to the power of n. Let's look at an example. We want to find the Maclaurin series for the function g of x is equal to sine of x squared, and we want to find its interval of convergence. Well, we could do this by taking consecutive derivatives of the function and evaluated them at 0 and then making up our series with the formula we have. Or we can use the fact that we already found what is the Maclaurin series for the functions, let's call it f of x equals sine of x. This is the sum from 0 to infinity. We have a factor of negative 1 to the power of n. We have the powers of x to the odd numbers only, so x to the power of 2n plus 1, and all of this divided by 2n plus 1 factorial. So that means that to find the Maclaurin series for g of x, according to the part B of the theorem above, we are going to have to substitute x by x squared. So let's do that. X equals n equals 0 to infinity. Still negative 1 to the power of n. Still we're going to have the factorial dividing. But now instead of x, we have x squared, and then all of that to the power of 2n plus 1. This means that we have the sum infinite sum from 0 to infinity, negative 1 to the power of n, x to the power of, and now we need to multiply the exponent, so we have 4n plus 2 over 2n plus 1, all of that factorial. What we are missing now is to find the interval of convergence, but I believe it was an exercise for you to find what is the interval of convergence for sine of x. So if you haven't done it yet, you should do it now and also find the interval of convergence for this new series. We could add to this theorem a part D and a part E, telling us how to find power series associated to f of x multiplied by g of x and f of x divided by g of x. However, we're not going to do it. Those formulae are rather complicated. The ones on your book are actually wrong. And we're going to show later on an example how, without knowing the formula for this, we can do it by hand.